Okay, a while ago, a student asked me how we can make money with math, and I told him, okay, you can solve some math questions. For example, this one right here. Of course, there are others, such as the Riemann hypothesis, but this is the one that I told him, and I think it's really easy to understand, but yet we don't have a proof for this yet. And I believe they did offer some cash prize, once again, it's $1 million for this right here. Anyway, Goldbach's conjecture says, every even integer greater than 2 can be written as the sum of 2 primes. And this, as I said, it's really easy to understand, but yet we don't have a mathematical proof for this. And then I demonstrate a few examples in, and of course, notice, even integer greater than 2. So we have to start with 4. So let's look at 4. Of course, 4 is the same as 2 plus 2. This is a prime, this is a prime, so this works, right? Notice, 1 is not a prime, so do not write 4 as 1 plus 3. So but we have an answer for this. And of course, I did a few more examples, such as 18. And of course, I asked the student, okay, give me 2 primes to come up with 18. Well, 13 plus 5. That's 18. Or you can also write this as 11 plus 7. So that's nice. And then we did a few more examples. We can do 20 right here with you guys. This right here, I can write here as 3 plus 17. And let's see. 7 plus 13, why not, right? 7 plus 13. That's pretty much it. And of course, there are a lot more. And of course, the student will ask, okay, it seems pretty legit, so we can just say this is true. Now, why do we need a proof? But the problem is that we can only do a finite amount of examples to verify. I believe there are people who have done examples up to couple million, right? But as I said, we do not have a mathematical proof for this. And if you guys can prove this, you can be famous. All right, so to illustrate the idea, I also told him the following. Why a proof is important, not just examples. So I told him this one right here. And I think when I write this down, a lot of you guys will notice right away. Let's consider the sequence Pn. This right here, I'll write it as n squared plus, let's do plus n plus 41. The minus version, there's also another one. This is another version as well. But let's look at this one right here. All right, cool. So notice, let's just come up with some examples again. Let's see. Right here I have n. Right here I have my Pn, which is, of course, just that. N squared plus n plus 41. Starting at n equals 0. When you put 0 right here, you get 41. That's nice. And then next one is, of course, 1. And then you can just go ahead. Putting 1, this is 1 squared, which is 1 plus 1 is 2. And then plus that is 43. So that's nice. And then you can continue. When n is 2, you get 2 squared, which is 4 plus that is 6 plus that is 47. And then let's do a few more. Let's say 3, which is going to be 9 plus 3, which is 12 plus that is 53, right? And then you can do one more if you like. This is going to be 16 plus 20 plus that is 61. And of course, so on, so on, so on, so on, so on, so on. Notice, we just did 5 examples right here. And all this right here, they seem to be prime. So, can we claim that this right here, it's let's say, like a prime sequence? Because it seems like at the moment, I can just plug any n value that I want, and then the output will be a prime. It doesn't give you all the primes, such as it doesn't give me 13, but the outputs right here, they are primes. Can I do that? So that's a question to ask. Well, this is an example that it's really crazy because this statement will be true for n equals 0, 1, 2, 3, 4, up to 39. Plugging 39 into the n's right here, work this out, you will still end up with a prime number. However, the moment you put in 40, this is not prime anymore. I'm not going to compute it in the regular sense. I will show you guys this way. So right here, let's observe the OBS right here. When n is equal to 40, putting 40 into all that, so we're looking at P40, which is 40 squared plus 40 plus 41. As I said, I'm not going to use a calculator to show you what the value is. Look at this and that. They have 40 in common, so I can factor that out. So we get 40 right here. And then from here, don't forget this is 40 squared, so I will have 40 left. And then this was 40, I factor out the 40, so I have 1. And then this right here still have the plus 41 right here. And look at, this is just 41, so 40 times 41 plus this is 41. And this term and that term, they both have 41 now. So I can factor that out. 41 times 40. Ah, look. P40 is equal to 41 times 40. And in fact, you can have a lot more factors, but I just show you the result right here. This is not a prime, which is a composite number, which is really crazy. You guys can check. When n goes from 0 to 39, and maybe you guys can leave a comment down below and let me know what this prime is. This right here, they are all primes, but the moment you put in 40, this is not prime, right? Because we just did that. In fact, can you guys give me another example that to show me this right here, it's not a prime sequence. So it's not prime sequence, it's not prime generator. It's an example that it will fool you for like the first 40 because we have from 0 to 39. And yeah, it just doesn't give you, in fact, if you plug in -1, that will also work because you get +1 minus 1, which is 0, and then you get 41. But no, this is not a prime. So this right here is a pretty good example to show that why we need proof, not just examples like this. And of course, if you guys can prove this, you'll be famous. Anyway, hopefully you guys all like this video. If you are new, be sure to subscribe. Thank you. As always, that's it. I forgot about that.